Hello everyone. Let's start with the disclaimer first. And today's topic is about design a small application with pluggable modulus to collect data. And I'm planning to show you how to use drawio. We will create some kind of sketch of the design. And while we will design the application, we will also cover the following topics. They are drawio, plant UML, and component and sequence diagrams. Both of them are quite useful, but in the specific use cases. So let's jump into it. To use the drawio, what we need to do is go to the Chrome, for example, and then type draw.io. Or where to save these diagrams. So far we can say that we would like to decide it later. If you want to drag and drop the diagram, for example, you press the right click and then you can move it while you're holding the right click button on your mouse. Press Ctrl and then with hold it Ctrl, then you can increase or decrease the size. Let's try to design our application and connected library. So let's define the main application first. All right, so as I discussed firstly, we have the small application and we will have so far just a library which will be loaded to the application, and it means that application can call a function from library and library will have an implementation of this function. So what we will do right now, we will add here an interface. In our case or in our context, what we mean under interface, that it is kind of the header file which will be included both in main application and in library. So main application will include that header file and will know that there are some specific variables or functions defined. And the library module will include this header and will also define functions, and if it is needed, also define some variables specified on header. So this interface, I would say, in our interpretation is kind of a declaration, if I can say so, or the content of header file which should be known in both sides, in main application and in module. Our interface, I would probably call it not interface, but I will also add here in parentheses header. Let's discuss it. We can try to do our best and guess the main set of functions that module should provide, but we are not, can I say, safe, or we can't predict the future. So there is a chance that the set of functions will be changed. One of the ways how to solve this problem, that's not only one way, it's one of many, is to define, first of all, a function, the simplest function ever, that will just return some value which is indicating the version of interface. iFace version, 0 arguments, and it will return smallest variable possible for us. And I don't think that we will create a solution which will have more than 250 versions. And it means that we can use a byte to store this data. And I guess that we don't need to use here some negative values. So we will use 1 byte and it will be unsigned. We can go with a new type. It is unsigned int 8t. So it means that it is unsigned, it is integer. So it has natural numbers, 1, 2, 3, 5, blah, 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 255. And it means that we have one function, just return the version of interface used. That will be a bit easier for us because we will know, for example, what of the structures or what the values is it, and etc. Let's connect it. Main application includes interface just to know the version of the component, and module will use interface to declare the function, which will be called by main application, and we will just return the interface version. Now let's create another interface. We will move it here and we will call it interface version 1. What does it mean for us? That might be a separate header file, that might be a separate namespace. We will see what we are planning to do. So far, let's imagine that we have a separate header file and separate namespace. I guess that will be beneficial because in this case we might have multiple headers, we might have multiple versions, we will have backwards compatibility. We can discuss, we can be more flexible with this option. Let's try to simulate the abstract future that we have implemented the interface already. Or maybe some abstract developer has received our API to them to implement a module, or maybe to write an application and use this module. So I would expect that interface with version 1 will provide, first of all, the enumeration of what type of data can module provide. So let's imagine that it might provide integer values, it might provide float values, string, and we will discuss how to provide strings. What else? Let's imagine that it might provide an array of float values or an array of integer values. So it will be int and float. That's it. When we are talking about strings, usually that means that we have a pointer to allocated data and then we have size of this data. For integer and float values, we can just define two functions with specified return type. And now we have interesting point, string. We can write a structure which will hold a pointer to a data for the given type. Again, we are talking about some nasty solutions right now, not the best one. I'm just showing you some cases when we are designing something, and it is version 1. So probably with version 137 I get more or less nicely designed solution. So far it is a bit ugly, chunky. We will define the structure, and this structure will have inside a pointer of the type void, which we will convert to either string or characters, integer or float. Then we will have uint 8t size of this array of data. And to be able to understand what type of the enumeration we have, then we will also add here enum, that one which we defined on top. And also I realized that probably it is nice to have here a kind of indicator that something goes wrong. So we will add to this enumeration a value which is called unknown. We can define our function, let's call it here struct value, and it will return the struct. I understand that right now it looks a bit strange and has a bunch of the questions, let's say, and it is not understandable, but I will try to explain it. Imagine that we have a main application and we have some module. Module is a library. So from the side of the application, we will call the function interface version just to know what version we are working with. And if it is the version number 1, then we will call functions received from the interface version 1. So we know that it is enumeration. So then we will know that with interface version 1, the library or a module loaded will use enumeration to indicate the type of data sending to the application. And also if it is something related to the arrays like string or integer or floats, then it will return us a structure. And then it will have three functions for us. It is integer value, float value, or structure value. So if we call structure value, it will return us an object of struct, which will have the pointer to the data of allocated data, amount of elements, so we know how many elements we should read, and then the type of this data, store it as an enumeration. And if something is happening badly, for example, an error accurate or something similar, then unknown type will be stored inside this enumeration. So let's try to summarize what will happen here. The main application will include two headers. The first one is interface as general, and that header file will include only one function. A module will define this function, iFace version, and will return either 0, means something has happened, an error accurate, blah, 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 or the number of interface, in our case, just 1. And if module has provided a version number 1 in iFace version, then main application knows, okay, then we should expect some enumeration and structure, which holds a header file interface v1. And this module will provide for us three functions right now. It is to get integer value, float value, or some structured data, which has a pointer to allocated data, size of this allocated data, and type of this data stored in the enumeration. I know that right now this diagram might cause more questions than answers, but it is part of the design. So we will jump to the sequence diagram now to go through the kind of sequence what is happening and how, so it will help us a little bit to understand or plan our work. And let me first try to answer what is the sequence diagram. Sequence diagrams usually help us to understand the flow of the calls, of the function calls. What goes first, what goes after, what function is returning what values, and etc. So it will help us to understand the dependencies between functions, or maybe the dependencies between modules. Sometimes when we are visualizing the code by using sequence diagrams, we can see that we are depending on 2 or 3 functions which are called in parallel, and then if we have a multi-threaded program, we might see possible cases when we have erased conditions and some other problems. So let's draw a simple sequence diagram first. So we have an object. In our case, it is main application. Let's call it here main app application. And since we have these two interfaces defined as an interface, we just have a library module. Let's call it as module 1. We don't have anything else right now, just module 1. And let's add as an actor. So basically, we have an actor. It is an user. Usually it means that actor starts an application, actor triggers an event or something similar. So it means an external communication or external interaction with the component. So imagine that actor runs main application, and it means that we just clicked double click on the main app or call it from the command line, and we activated it. So from this point, it means that main application is running. And let me increase it. So let's imagine so far. And we will just make it really long line so far, because we don't know how long it will run. We will fix it a bit later. Then once main application is starting, we will add here also a line. So we will add here this line to module, but we will move it up. So it means that right on the startup, so when main application is starting, it will load the dependencies, in our case module 1. And when I saying that it will load the module 1, I mean load into the memory. So it will not direct communication towards module as a calling function, but it means that system will load the main application into memory and then see, oh, this main application is depending on module 1, so it will read module 1 to the memory and then make it accessible from the main application. But it doesn't mean that main application makes actual call to a function of module 1. It is just loads it into memory. But now let's imagine that our main application as a startup should call a library to get an interface version. And we can use this synchronous invocation to indicate it. So we move it here. And we connect these lines to the main application. As you can see here, it's called dispatch. We can call it here, for example, calls iFace version, just to make it a bit easier for us to understand. And it returns some value. In our case, 1 as a good situation. And now what we can do, we can explain, or we can use a frame here. So for example, in frame we can write while loop, or we can write here a loop while application is running. As you can see here, there is no space to fit all text, but we can move it here to fit everything what is needed. And what does it mean? That in this frame, we should fit all in operation that we would like to have inside a loop. In our case, it is synchronous invocation, or a call that we will do from the main application and base it on... you see, there is a problem. We can send integer value, float value, or structure value, but we don't know what value is provided by module. So we forgot to add here. Let me write here. We need to add the function what type of the data will be reported. So we know what the type of the function should be called. So it means we will write here type of value, and it means that it will return a enum for us. Yes. And it is a bit changing the game, because based on type of the value, we should call one of these 3 functions. And it means that everything what is inside this frame should be moved down so far. And it means that this activation bar can be then moved down. And we should repeat this action here and move it. Oh. What is this line? Let's remove it. That's not our. And we will add here another function, or another dispatch. I don't know what happened to his main application. Something happened with main application. Well, it happens. Drawio, you are majestic. So in our dispatch function, we move it to main application and we call here calls type of value in v1, and it will return enum. So now it makes sense. We call the iFace version. It returns some values, version. Then we call type of value. So we will receive this enumeration. We will know what type of the value we will receive. So for example, integer value or maybe float value, maybe strings. And then based on this type, we will call the necessary function. So what we will do here, we move this line again. Here in dispatch, we will call correspond function depending on enum. Now it makes sense. So, and now the sequence diagram clarifies a little bit that this activation bar is located in the wrong place. Now it's fixed. So, with sequence diagram, we can imagine, simulate, and also clarify the kind of flow of the function calls in our application or in our solution, maybe in our library. As you can see here, the actor loads an application, and once it is loaded, then we are calling interface version. Then we receiving a type of the value, and then inside a loop while application is running, that actor doesn't stop it. Then we call correspond function. So it was either int value or float value or struct value. And then module will report this value. So what is left here is to add kind of self call. And here we should write print value from the module. So we have received this value and we would like to print it, as well as and ask user to continue. Let's do this simple idea. So we will print a value, receive it from the module, and also we will print the message to a user. And if user would like to stop the loop, then we will exit it. Otherwise, we will continue it. What is left here? Let's think about it. It is... I don't know what is happening with main application, to be honest. That's some strange. But what is left here probably is to add here another call, and it will be related to sleep. So let's increase it here. All right, so when we will print a value from the module and then ask user to continue, probably it is good to have here kind of sleep function or some timeout. So we will print a value periodically, for example, every second. Otherwise, we will spam the poor user. So we will add here another call, self call here, which will mean that we will do sleep call. So let's call it here sleep for 1 second. And so actor or an user starts an application, calls iFace version, then version will be returned. Then it is one-time action. Then we do one-time action is receiving the type of value. And then we do inside a loop, we call the correspond function, print value and ask a user to continue. If user doesn't react on it, we will just sleep for 1 second and then we repeat this loop. So again, call the correspond function and etc. I was thinking to repeat it 10 times. I was thinking to repeat it 10 times. I was thinking to repeat it 10 times, but I don't want to spend too much time on it. That's an idea. Yes. So that's an option how to use the sequence diagram, which will help you to understand the flow of the function calls. The main problem here is that sometimes to write or to create the sequence diagram, it might take big amount of time and it will quite long. So there is pros and cons of using the sequence diagram. So far we have some diagram or component diagram. So we have main complication and library, and we have some interfaces and also kind of illustration of how to use it. And by the way, you could see that while I was creating the sequence diagram, we realized that there is one missing function, and it is without writing a code so far. So let's save this diagram. So I have saved it locally. I think that we will stop here, and I will record a separate video related to the plant UML, since I would like to keep videos short. So on the next video, we will do basically the same or quite similar stuff, but related to the plant UML. Thank you for watching your time and see you in the next video. Bye.